So these are the two stars, star Y and star X, and these are their radii. So Ry and that is Rx. So in this question, we have to find out their ratio. But how can we find the ratio? We are given the condition that if they have the same luminosity. So when we say the two stars have the same luminosity, it means that irrespective of their difference of sizes, they both are emitting, both are radiating same amount of energy per unit time. Okay, so that what means luminosity, same luminosity. So and also one more thing, the x have a temperature, Tx is equals to 2 times the temperature of y. So let's try to calculate. So first of all, I will give you the reference of Stephen Boltzmann law, okay, which says that intensity is proportional to the fourth power of temperature. Okay, but our curriculum has changed, so I would say that apparent brightness is proportional to T raised power 4. So students, when we will place a constant, so the constant is Boltzmann constant and T raised power 4. And we are considering these two stars black body because they have not given any value of emissivity. Okay, so we can consider here the one value 1, otherwise we will write the letter E as well. Okay, now the apparent brightness is equals to luminosity over the area. Okay, which area? The area of the sun or the area of the star. Okay, now that area is, in other words, we can say, or right now if we are talking about the luminosity of the star, then that's why this area is the area of the star. So 4 pi, I am writing 4 pi r square is equals to sigma T raised power 4. Okay, so whenever we are talking about the luminosity, or we are solving a problem in which we are focusing on the surface of star, okay, we, just like in a previous question, you can see in this diagram, we were talking about here the brightness of the light away from the star on the surface of earth, and that's why here you can see I have written 4 pi d square, which is the area of this imaginary sphere. But right now this 4 pi r square I'm writing because this is the area of this spherical star. Okay, anyway, so what formula do we get from here? So L is equals to sigma into 4 pi r square T raised power 4. Now you can simply solve because we have got an equation. So 4 star x. So students, you know that they both have same luminosity. So I will write L is equals to sigma is a constant into 4 pi r x square, and the temperature is Tx raised to power 4. And in the same manner, we will write an equation for the star y. And what should we write? Same luminosity, so L is equals to constant into 4 pi r y square T y raised to power 4. Okay, now can we equate these two? Because the left hand side of equation is same, so when we will equate, so we must have sigma into 4 pi r x square T raised to power 4, so T y raised to power 4. Okay, so now we can cancel these 4 pi and 4 pi on the both sides, and we can see that we are getting a ratio. In fact, rx square over r y square is equals to, so that is a inverse ratio. Okay, so raised to power 4. And for more better and simple method, we can bring it in one bracket and we can take whole raised to power 4. Okay, so we want to find out the ratio of this, like rx over ry. So don't you think if we take a square root on both sides, or you can also directly put the value of the tx. Okay, so both things are right. So I will write here ty over 2ty. Okay, because temperature on the star x is 2 times over temperature on the y raised to power 4, and it will become 1 over 2 raised to power 4, and that will become 1 over 16. And now, because we have to still take a square root, so when you will take square root, so that must be equals to 1 over 4. So which means that, in other words, which means that the ry is equals to 4 times rx. So it means that the star y must be of a larger size than the star x. So the right answer is option B.